Hello students, welcome back to Engineers Academy. Do hit the subscribe button if you are here for the first time. It's the first problem of chapter 2, Engineering Statics by Meriem and Kraige, 8th edition. And the problem says that the force F has a magnitude of 800 Newton. Express this force F as a vector in terms of the unit vectors I and J and identify the X and Y scalar components of this given force. So we are given that this force is acting in this particular direction and it is making 35-degree angle with the positive y-axis, and this force has a magnitude of 800 Newton. So as we can see that this force F will have two components. One component will be along the y direction like this, and we will have one component in this direction. And always remember that this f of y and this f of x component, they will always start from the tail of this actual force F. So we will have f of y in this direction and we will have f of x in this direction. So let me draw these two components. We will have f of y in the positive y direction. This is f of y, and we will have f of x in the negative x direction. So this is f of x. So these two components will start from the tail of this given force and they will go in the direction of this arrow of the given force. So as we can see that this force F is starting from O and it is going up towards this arrow is going up towards the positive y direction. So that's why we are having the f of y component in the positive y direction. And similarly in the x direction, this arrow is towards the left of the positive x-axis. So that's why f of x is acting towards the negative x-axis. And if we add both of these components, if we add f of x and f of y by head to tail rule, they must give us this force F. So this is f of x, and if we draw f of y by head to tail rule, the tail of f of y, must coincide with the head of f of x. So f of x plus f of y by head to tail rule, they must give us that force F. So we can say that F vector is equal to f of x vector plus f of y vector. So if we add both of these by head to tail rule, the resultant will be equal to that force F which is given, which is having a magnitude of 800 Newton. Now as you guys can see that this force F is making 35-degree angle with the positive y-axis. We can add f of y and f of x in any order. So we can show that f of x here as well. So this is f of x. So now as you guys can see that this is a right angle triangle. Here we have 90 degrees. Since this f of y and f of x, they are the rectangular components. Those components which are making 90 degree with each other are the rectangular components. So the f of x and f of y are the rectangular components, and this triangle is a right angle triangle, and this force F is the hypotenuse of that right angle triangle. So this is that 35-degree angle. So considering this right angle triangle, this force F is the hypotenuse, and for this angle this f of y is the base and this f of x is the this is the perpendicular. So now if I apply cos of 35 to this right angle triangle, then we can say that cos of 35 degrees will be equal to the adjacent side divided by the hypotenuse. So we can say, let me write that f of y is the adjacent side and this force F is the hypotenuse, and f of x is the opposite side to the angle. So we can say that cos of 35 is the adjacent side of the angle divided by the hypotenuse. Or we can say that sometimes this adjacent side is known as the base as well. So this is the base and the opposite side is perpendicular. So we can also say that cos of 35 is the base divided by the perpendicular. Now cos of 35 is equal to, now the adjacent side is f of y divided by the hypotenuse, which is that force F. So we can say that cos of 35 degrees is equal to f of y divided by force F magnitude, which is 800 Newton. And if we multiply both sides of the equation with 800, then we can say that f of y is equal to 800 cos of 35 degrees. Now remember that if we are given the angle with the adjacent side, then that adjacent side will always be the cos component. Remember that f of y is the cos component. And similarly, if I apply the sine of 35 degrees, if I apply sine of 35 degrees, then we can say that sine of 35 will be the opposite side divided by the hypotenuse. Or we can say that the perpendicular divided by the hypotenuse. And this is equal to, now the opposite side is f of x and the hypotenuse is that force F. Now if we, so this is f of x and f is 800, and if I multiply both sides of equation with 800, then we will have f of x equal to 800 sine of 35 degrees. So we can say f of x is 459 Newton approximately, and similarly f of y is 800 cos of 35, which is 655 approximately. So we can say that f of y is equal to 655.321 Newton. Now in the problem statement, we are asked to write that force F in terms of the unit vectors I and j, and identify the x and y scalar components of that force F. So the scalar components, so for the scalar components, is we can see that f of x is in the negative x. So then we can say that f of x will be equal to minus and then that magnitude, so minus 459 Newton. So this is the scalar component f of x. And similarly we can write that f of y is equal to plus 655 approximately. Let me remove these 0.321, so 655 Newton. And similarly, if we write these f of x and f of y as vectors, then we can say that f of x vector is equal to that f of x magnitude multiplied by its corresponding unit vector. So since f of x is acting in the x direction, so in the x we have the I unit vector, so f of x multiplied by that I. So f of x is the scalar component, which is minus 459 into unit vector I Newton. And similarly f of y vector will be equal to plus, or we can say f of y unit vector j will be equal to plus 655 j Newton. And similarly we want to write that force F as a in terms of I and j. So since we know that f vector is equal to f of x vector plus f of y vector. So f of x vector is this minus 459 I, and f of y is this 655 j, and the units are in Newton. So this is the representation of that force F in terms of unit vectors I and j. The component which is adjacent to the angle is always the cos component, and the component which is opposite to the angle is always the sine component. So now if we consider this angle, so this angle is, we know that this angle will be 90 minus 35, so we can say 90 minus 35, so this is 55. So let me write this angle as 55 here. So this is that angle 55, and now again we can draw those components. So this is our f of x, and this is that f of y. You guys can see again I have drawn those two components. This is f of x, this is f of y. Now we are considering this angle 55. So now the adjacent side is f of x. So the f of x will be the cos component in terms of this angle. So again we can say that f of x will be equal to that 800 cos of 55 and we will get the same answer. So 800 cos of 55 is 459. So we got here 459 as well. So f of x is 459 Newton. Let me write it. 459 Newton. And similarly for this 55-degree angle, f of y is opposite to this angle, so f of y will be the sine component. So we can say that f of y is equal to 800 sine of 55 degrees. So 800 sine of 55 degrees. So this is 655 Newton approximately. And since f of y is in the positive direction, so 6 plus 655, and f of x is in the negative x direction, so we will write minus. So these are the scalar components of that force F. So in the next in all of my videos, I'm not going to use this cos of 35 and sine of 35, and I just use this thumb rule that the component which is adjacent to the angle is always the cos component, and the component which is opposite to the angle is always the sine component. So do remember this point and let me know if this helps. Do subscribe Engineers Academy for the solution of such more problems from Engineering Statics by Meriem and Kraige.